Have you ever wondered just how vast the universe truly is? Let's embark on a cosmic journey into the heart of the seemingly infinite expanse we call space. Space, the final frontier, is not just a void, but a cosmos teeming with energy, matter, and motion. It's a vibrant, dynamic place filled with galaxies, black holes, stars, planets, and much more. The sheer enormity of space is beyond human comprehension as it stretches out seemingly without end in every direction. Let's attempt to grasp this immense scale. Imagine the Earth. Now picture 100 Earths lined up. That's about the diameter of the Sun. But the Sun is just a regular star in our galaxy, the Milky Way. The Milky Way, this swirling mass of stars and cosmic dust, is so large that light, traveling at a speed of 186,000 miles per second, would need about 100,000 years to cross it from one end to the other. Yet, the Milky Way is but one galaxy among an estimated 2 trillion galaxies in the observable universe. Each of these galaxies is a sprawling city of stars, much like our own Milky Way, teeming with planets, moons, asteroids, and comets. If we were to shrink the universe down to the size of our Earth, our Milky Way galaxy would be about the size of a dinner plate. And Earth, it would be smaller than a grain of sand. But space isn't just about size and distance, it's about time too. The light we see from distant stars and galaxies isn't how they appear now, but how they looked millions, sometimes billions of years ago. So while we gaze into space, we are also looking back in time. Indeed, the cosmos is a place of unimaginable scale, and we are but a tiny part of it. As we continue on this journey through the universe, let's marvel at the vastness of space and our unique yet humble place within it. Stars, like humans, have a life cycle. But what exactly happens when a star is born or dies? Imagine a massive, swirling cloud of dust and gas in the depths of space, much like a celestial whirlpool. This is a nebula, the birthplace of stars. As gravity pulls these particles together, a dense, hot core forms. This is a protostar, the first step in a star's life cycle. As the protostar continues to grow, the pressure and heat at its core increase until nuclear fusion begins, and voila, a star is born. Just like a caterpillar morphing into a butterfly, the protostar has transformed into a main sequence star, like our very own sun. But stars don't stay in this stage forever. Depending on their mass, they will meet different fates. Smaller stars, once they've exhausted their nuclear fuel, will cool and shrink into white dwarfs. Imagine a once roaring bonfire reduced to smoldering embers. Larger stars, on the other hand, will undergo dramatic supernova explosions, leaving behind neutron stars or, in the case of the most massive stars, black holes. Picture a grand firework display marking the end of a grand event. But whether they end up as white dwarfs, neutron stars, or black holes, all stars contribute to the cycle of matter in the universe. They enrich the cosmos with the elements necessary for new stars to form, and the cycle continues. In the grand theater of the cosmos, stars play out a dramatic life cycle, illuminating the universe with their brilliance. Black holes, the most mysterious objects in the universe. What do we really know about them? Let's start with the basics. A black hole is an area in space where the gravitational pull is so strong, nothing can escape it, not even light. This is why they're called black holes. They're invisible to the naked eye. But they're not empty voids. They contain a huge amount of mass packed into an incredibly small area. This creates a gravitational field so strong that anything close by gets sucked in. Imagine a star 10 times more massive than our sun, compressed into a sphere approximately the size of a city. That's a black hole. So what happens when something falls into a black hole? Well, it gets stretched out into what's known as a spaghettification process. It's a bit like pulling a piece of chewing gum, except it's an entire star or planet being stretched into a long, thin strand of matter. Now let's talk about the event horizon and singularity. The event horizon is the point of no return. Once something crosses this boundary, it can't escape the black hole's pull. And at the very heart of the black hole, we find the singularity. This is where all the mass of the black hole is concentrated into an infinitely small point. Recent research and theories have led to fascinating possibilities. Some suggest black holes could be portals to other universes, while others propose they might be the key to understanding the very fabric of our own universe. Black holes remain one of the greatest enigmas in our understanding of the universe. Are we alone in the universe, or is there other life out there? This is the question that has captivated humanity for centuries. The search for extraterrestrial life is an endeavor that combines the curiosity of human nature with the rigor of scientific investigation. At the heart of this search is the quest to find conditions that could support life as we know it. Life on Earth thrives in a diverse range of environments, but some basic requirements are universal. Water, in particular, is a key ingredient for life as we know it. It's a solvent where chemical reactions necessary for life can take place. Hence, the mantra for astrobiologists, scientists who study life in the universe, is follow the water. Over the decades, we've honed our technology and sharpened our understanding of what to look for, from listening for signals from potentially advanced civilizations to searching for microbial life within our own solar system. And indeed, within our cosmic neighborhood, there are several tantalizing possibilities. Mars, our red neighbor, has been the focus of numerous missions, with its past signs of flowing water and a tantalizingly Earth-like climate in its ancient past. But it's not the only place in the solar system with potential. Jupiter's moon Europa and Saturn's moon Enceladus are both believed to harbor vast oceans beneath their icy surfaces. These oceans, warmed by the gravitational pull of their parent planets, could potentially support life. We've even found hints of water vapor in the atmosphere of distant exoplanets, worlds orbiting other stars. The search for alien life is a journey of exploration and discovery. It's a testament to our curiosity, our ambition, and our relentless pursuit of knowledge. As we continue to probe the cosmos, we're not just seeking to find if we are alone, but also striving to understand the very nature of life itself. The search for alien life continues, and who knows, perhaps one day we'll find that we are not alone in this vast universe.